All right, so let's have a look at what we know. We are told A of 3 equals 0, which means that area in orange must equal that area in green, because they will counterbalance each other out, because we start from -3 onwards. We also then can safely say that at x equals -1, that's going to be the minimum, because that orange, the value of that area in orange, well, that's going to be a negative integral value, and it's going to be the highest negative at that point, which is pretty handy because you're told that A of -1 is -9. So you know that is the minimum. That has to be the minimum point. And then we start at -3, because when we integrate from -3 to -3, we get 0. So that'll start there. And then you know, therefore, you've got this x-intercept, or the root, if you want. That's going to be -3, 0. We know there's a maximum here. And then where's that point of inflection going to be? At 1. Okay, so because that's where the maximum here of the graph is, so that's how we know it's going to be at 1. So you've got to label that, because it does say labeling all the different points. So you've got some point of inflection happening around here at 1. Where's the max going to be? Yeah, at 3. So there's your graph, pretty much. Not the best. But you need to say that is a point of inflection. And this is the maximum, which is also the root, or the x-intercept. Because it says x-intercept in the question, I guess you should specify. But if you don't do those labels, you'll lose marks. So that happened better last year, but in the previous year, labelling of graph, not in this fundamental theorem context, but it was, I think it was some link to an exponential function context. Students didn't label and they lost marks for not doing that. So don't lose easy marks. All right, any other questions about that one? Yeah, because when we integrate, so this starts from -3 to -3. What can you tell me about so for an integral from -3 to -3 is always 0. Yeah, from one point to its same point is always going to be 0. Yeah. All right, last one. Let's have a go. So equation of the line determined by the gradient, rise over run, which is a half, and the y-intercept. I've used 5 on 2 only because I've used a half. There's no reason why you couldn't say 0.5t plus 2.5. Yeah, it is t, so we've got to go with the variable that's in the question. So use the increments formula. Do we actually need A? What we need is the increments formula. dA dx is approximately delta A, delta x. So we want to know the change in A. So we want to know delta A is approximately dA dx. So what are we actually trying to find here? Aren't we just trying to find the derivative of the integral? Which we know is f of x. So what we want is f of x times delta x, essentially. That's what delta A is. So your delta x is 0.1. So the x value starts at 7. Because 7 is the start point of the change. There it is there. So that becomes your x value. And then the difference from 7.1 and 7, that's where your 0.1 comes from, which is 0.6. So it's not really a difficult question, but understanding that connection, I guess, is the key here, and showing you how it's thrown into an incremental change question.
So you don't have to go and write the A equation?
No, don't need it, and that's the point, and that's the beauty of this. The derivative of the integral takes you back to the function. You don't even have to worry about what that integrated function is, because when we differentiate again, it just takes you back to where you started anyway. So we've got the integral of the derivative. So this is different to all the others, because all the others it was the derivative of the integral. Integral of the derivative, remember we just sub in and subtract. So f of 3 is 2 and f of 0 is -1. So the next one is just going to be f of 3, take f of 2, or f of -2, sorry. F of -2 is 4. So just finishing off, we know that the first derivative, the derivative function is positive for x greater than 0. So that's the graph of the function. So x greater than 0, these are all positive gradients. And all the way through here, you're going to have negative gradients, which means that's going to give you, that's going to be below the curve. So we need the absolute value of your answers from -2 to 0, whatever that is. And then from 0 to 3, regardless, that's going to be a positive number anyway. So that's going to be 3 plus the absolute value of -5, which is 3 plus 5, which is 8. And we're done.